So we're going to look at some of the practice questions for S1.3. So I'm in my practice sheet. We're going to go through now looking at the average female height. So we have 100 scores here, all representing the average female height in inches. First thing we're going to do is create a histogram. So I'm going to insert my chart, change the type to histogram, or I can select the data first. Change the data that I want. I want A1 to A100. And I can select that over here. And we have our histogram. Again, let's adjust our bin range a little bit, or our bucket size. Let's see what 1 looks like. That might be a little too much, so maybe we'll keep it at 2. This data looks a little more spread out than the male bucket size. Let's give this a title, female height. Label our axes. The horizontal axis is height in inches, and the vertical axis is number of women, right? It's the frequency. So I'll just squeeze this in here. Let's find the mean, median, and mode of our data. So the mean is 65.3. The average height of these females is 65.3 inches. The median, the middle, I lined these women up in a row. The middle woman would be 64.6 inches tall. And the mode, the most common height, looks like it's 62.61 inches. Right, that shows up most commonly. Standard deviation. So again, how far do I have to go from that mean, right, from that 65.3? How far do I have to go in either direction? Too many parentheses. And it looks like I have to go about 3.5 inches in either direction from that 65.3 to find out where 68% of my data is. So what is the average height is our first question. Well, that's our mean, right? When we say average, we're talking about the mean, that middle value in terms of adding all the values together, dividing by the total values. So the average female height is 65.3 inches. What height range do 68% of these women fall into? So remember, that means that I'm within plus or minus 1 standard deviation, right? I want to go 1 standard deviation, or in this case, 3.5 inches above my mean. I also want to go 1 standard deviation below. I want to go 3.5 inches below 65.3. If I do that calculation, so I'm first doing 65.3 minus 3.5, that tells me the low end of that range is 61.8 inches. And then I'm going to go 65.3 plus 3.5 to 68.8 inches. So again, that's within plus or minus 1 standard deviation. That means that 68 out of these 100 scores, right, are within that range, right? 68, the majority, over half of these women fall between about 62 and 69 inches tall. Right? And we can kind of see that if we're looking right in this middle range between about 61 and 69. I have 21, 46 plus 19 gives me about 60, right? 68. Miss LaRoche is 70 inches tall. What is her Z-score? So notice if we look up at this range, right, I'm outside of that 68.8 inches, so I am on the taller side. We can use that formula. Remember, Z-score is equal to value minus mean divided by standard deviation. So I'm going to go ahead and I'm going to know that my z-score is my value, which is 70, minus the mean, so 65.3. And then I'm going to divide all of that, right, the whole numerator, divided by that standard deviation. Again, I'm going to round that to about 3.5. And so my z-score ends up being, right, 70 minus 65.3 gives me 4.7. I divide that, right? I'm basically finding out how big the difference between me and the mean is in terms of numbers of standard deviations. It looks like I get a z-score of 1.34. So I'm 1 1/3 standard deviations above the average. Miss Lakhani, on the other hand, is only 64 inches tall, so she is a little bit below average, right? A little bit below that mean of 65.3, but not too crazy. Her z-score is going to look like 64 minus 65.3. Notice that's going to give us a negative number, right? Remember, negative z-scores mean you're below the average. Positive z-scores mean you're above the average. Divided by 3.5. I figure out that calculation. I have a negative 1.3 as my numerator, divided by 3.5, and I missed a decimal there. When I calculate that on a calculator, again, we don't really have a z-score formula here in Google Sheets, negative 0.37. Right, so she's only 1/3 of a standard deviation below average. Right, again, that's telling us how significant the difference from average is. Right, I am taller than average compared to Miss Lakhani, who is not that much shorter than average. So hopefully that can give you some more clarification around what standard deviation is, right, and what z-scores look like, and how we can find those values to tell us how a specific scenario, situation, my height versus Miss Lakhani's height, how those can compare to the average, right, to the mean.